Hi everyone. So I was just reading this paper for quite a few days now, and I just wanted to share like how to read a physics research paper. So this is my first time reading it, and I have read like uh, one or two papers. So I just wanted to share like what are some general things one should keep in mind while reading this that has helped me, and what we should not be doing. So, for example, this is a paper that I have been reading. So it says understanding cue balls beyond the thin wall limit. So you don't have to exactly know what a cue ball is to understand this video. It's just I'll just go through this paper and tell you what are the important things that we should keep in mind. So just imagine this cue ball to be a particle which is spherical. It's like a ball. So just read. So the first step is just to read the topic. Read the title of this paper. So understanding cue balls beyond the thin wall limit. So okay, we are like understanding some particle which is of a ball shape maybe, and it is like beyond the thin wall. Thin wall means like as we go from the center of that ball to the surface, we are not having a smooth surface. Rather, we are having a thick boundary. Okay, so then you just have to read the abstract first. Just read it. It genuinely has the content of what the paper contains, what the paper is about. Just read it. So for example, I have just marked out one important line from this which exactly tells you what the paper is about. It is like, in this work we derive analytical approximations for cue ball in polynomial potential and obtain simple expression for the important cue ball properties of charge, energy and radius. As simple as that. They are just telling you what they are deriving in this paper. So they derive some cue ball profiles in polynomial potential, and they derive the expressions of charge, energy and radius. Okay, great. We know what we are going to study in this paper. Don't read introduction right after the abstract. Just go to the conclusion once. So if you go to the conclusion, this is the third step. So first step is just reading the title. Second is just reading the abstract. Now just read the conclusion once. Again, I have marked some important lines. They say we can describe stable cue balls in arbitrary U1 symmetric 60 potential to about 10% accuracy and much better for larger cue balls. They are just telling you what they did in this paper, and they have achieved things up to 10% accuracy. Okay, great. Now I'll be reading this paper and I'll keep in mind whatever I have been studying. It is like they have done it successfully up to 10% order. Great. They also say finally our improved description of global cue balls paves the way to better description of significantly more difficult gauged cue balls. Great. They are just telling you ki keeping this study as the base, we can further advance these properties and whatever the equations are derived in this paper to something more general gauged cue balls. It is just saying that this paper can act as a base for further improvements. Great. So whatever we are reading now, we know what will be the end conclusion of this and what we are exactly studying. Now come back to the introduction. Introduction has everything related to the history of this, like cue ball or say whatever research paper you are reading. It contains the history of on what shoulders this paper has been built. Okay, so all the references, most of the references you will find in this introduction part only. So now that you have read the introduction, the abstract and the conclusion, so you know exactly what we are going to have in this paper and what the paper is about. Of course, you have some basic preliminary idea already what you are reading. That's why you are reading it, right? Now the process is over. Like honestly, you just have to use brute force now. You just have to use your pen, use your paper and derive every equation written in this paper by yourself. Try working this out. There will come times when you will stuck at this, like you will stuck at how to derive this equation. It's totally fine. Take your time. Like physics can only be improved by like using your pen and using your paper and using your mind. Like honestly, whatever time it takes, just let it be. Just derive, take your time, and you'll encounter these graphs occurring. You have to analyze them, like what if we change the value, what if we change that value. You have to analyze them as well. That will just boost your understanding about whatever you are doing, whatever the equations are. So for example, this is one graph, and I just like to code these graphs in like myself in Mathematica. For example, I have like done this. So we change the parameters and we get what will happen. So this is simply what the procedure is and what I did for this paper, and it took time. Like it took really weeks to understand this, and sometimes it took me days to derive like 2 or 3 equations. It's totally fine. That's why I'm pursuing this, and that's what we have to do, like to learn physics. Okay, thank you. This